present about probability experiment titled Picking a Sweet. Our group conduct a simple experiment using 3 sweet flavors. So, let's start now. For the background of our study, we choose an activity which is picking a sweet. We use 3 flavors sweet, which is apple, orange, and strawberry. A total of 30 students participate randomly, and each flavor was prepared in the same amount so that every sweet has an equal chance of being chosen. To make this selection fair, we use a digital spin wheel. So, let's move to the objective of the study. First, to record the frequency of each sweet flavor chosen by 30 students. This means we observe how many times each flavor is picked. The data help us to see if some flavors appear more often than expected. Second, to calculate experimental and theoretical probability for all flavors. Theoretical probability is what we expect to happen, while experimental probability is based on the result we get. By calculating both of them, we can compare whether the real outcome match our expectation or not. For the third, to compare both probability to see the differences. The steps show us if randomness affect the result or not. Even if all flavors have equal chance, real-life result may still vary, and this is what we want to highlight. So, this study is very important because it can help students to see clearly the differences between theoretical probability and actual experimental result. Through this activity, we can compare expected outcome with real data and understand why they don't always match. It also teaches us how to collect data and interpret results properly. Overall, this activity make the concept of probability easier to understand and apply in the real station.
I will walk you through our methodology for determining the experimental probability of selecting 3 sweet flavors. Our experiment was centered around a randomized spin wheel. This wheel was divided into 30 sections of equal size, labeled with our 3 flavors: apple, strawberry, and orange. We performed a total of 30 trials or 30 spins to collect our data. The people involved in this study were students from class RCDCS 143-3C. This entire group represents our population. From this population, we selected 30 students to perform 1 spin each. These 30 students form our sample. Population was students from class RCDCS 143-3C. Sample 30 selected students from class RCDCS 143-3C. The outcomes of the spin wheel form our sample space, which is simplified apple, strawberry, orange. After conducting the 30 trials, here are our results. 7 out of 30 trials resulted in the flavor apple. 5 out of 30 trials resulted in strawberry. And finally, the most frequently selected flavor was orange, with 15 out of 30 trials. This result now allows us to calculate the experimental probability for each flavor, which we will detail in the next section. But before we go to the next section, I will show you the example how we get our sample by using spin wheel.
we have 10 sweet for each three flavor, which is apple, strawberry, and orange. We managed to pull out apple flavor 7 times, strawberry 8 times, and 15 times for orange flavor. From this experiment, we can calculate experimental probability of obtaining each of the flavor. For apple, it will be 7 out of 30. For strawberry, it is 8 out of 30. And orange, 15 out of 30. Next, we can calculate theoretical probability of obtaining each of the flavor. It will be 10 out of 30 for apple, 10 out of 30 for strawberry, and 10 out of 30 for orange. With this information, we can find the differences between experimental probability and theoretical probability of obtaining each flavor of sweet. For apple, it is -1/10, which is -10%. It means out of 30 students, there is 10% chance of students will not draw an apple sweet over theoretical probability. For strawberry, it is -1/15, which is -7%. It means out of 30 students, there is 7% chance of students will not draw a strawberry sweet over theoretical probability. And for orange, it is 1/6, which is 17%. It means out of 30 students, there is 17% chance of student drawing an orange sweet over theoretical probability. Then, we can calculate the experimental probability the selected flavors are not apple, strawberry, or orange. For apple, it is 23/30, which is 77%. It means 77% of students did not draw an apple sweet. For strawberry, it is 11/15, which is 73%. It means 73% of students did not draw a strawberry sweet. Lastly, for orange, it is 1/2, which is 50%. It means 50% of students did not draw an orange sweet. So, to conclude our project, we found that orange was the most popular flavor, while apple was the least chosen. This was interesting because, in theory, all three flavors should have had the same probability. The difference between our theoretical and experimental results really help us to understand how chance and randomness can affect real-life outcomes. Through this project, we also learned how to compare theoretical and experimental probability and why the two don't always match perfectly. Besides that, we improved our data collection and analysis skill, which made our finding more accurate and meaningful. Overall, this experiment made learning probability more fun, practical, and easier to apply in real situations. Thank you.